Finally, the last group of operators we're going to look at is bitwise operators. Now, this really requires me to go beyond the scope of this course. I have to talk about some computer science stuff, and honestly, I don't really want to bore you because these stuff don't really have that much of practical usage in the real world. I'm not saying they're useless, they definitely have their own use, but they're more on the theoretical side and it's not something that you will use on a daily basis. However, if you're really enthusiastic, I'm going to explain what these bitwise operators are and how they work, but feel free to skip this lecture if you just want to focus on the practicality. So, you know that we humans use the decimal system to represent numbers. So 1, 2, 3, 4, 5. But in computers, these numbers are stored in the binary format, which is a combination of zeros and ones. So let's take a look at a few examples. The number 1 in the decimal system is represented as 7 zeros, 1, 2, 3, 4, 5, 6, 7, and a 1. So we have 8 digits. Each digit is what we call a bit. So here we have 8 bits, which represents 1 byte of information in a computer. Here's another example. Number 2 in the decimal system equals to 6 zeros and then 1 0. There are mathematical formulas behind this for converting numbers between decimal and binary systems. If you don't want to learn the mathematics, you can simply Google decimal to binary converter. Now, bitwise operators in JavaScript or any other programming languages are similar to logical operators, but they work on the individual bits of a number. Let me show you what I mean by this. So I'm going to do a console.log 1 or 2. Note that here we have a single vertical line that represents a bitwise OR. So bitwise OR. Logical ORs have double vertical line. Okay. So when we apply the bitwise OR between 1 and 2, this is what's going to happen. So I add R as the result here. Now, this operator is going to look at each of these bits like this in a vertical way. If either of these bits is 1, the result will be 1, otherwise it will be 0. So here, in both these numbers, the first 6 bits are 0. So in the result, we'll also have 6 zeros. Now, the 7th bit will be 1, because here we have 1 at this position, right? And similarly, the 8th bit will be 1, because here we have a 1. Now, if you convert this binary number to a decimal number, the result will be 3. So let's save the changes. And you can see on the console we have 3. Bitwise AND is similar. So let's duplicate this. Bitwise AND. We'll use a single ampersand for that. Now, the result is going to be something like this. So if both numbers are 1, 1 will be returned. Otherwise, the result will be 0. So in this case, all the bits will end up being 0. Because if you look at these two first numbers, 1 and 2, their first 6 bits are 0. And here in the second number, we have this bit that is 1, but the bit at the equivalent position here is 0. So if we apply the bitwise AND between these two bits, the result will be 0. Okay? So this binary number equals 0 in the decimal system. Let's save the changes and see this on the console. Save. Here it is. So this is the fundamental of bitwise operators. Now in JavaScript, we have a few more bitwise operators, but in the real world, they're not that common. Now let me give you a real world example of when we can use these bitwise operators, so at least they make sense to you. Imagine you want to implement an access control system. So the user can have these permissions: read, write, and execute. Now, we can use 1 byte of information, or 8 bits, to determine the kind of permission a user can have. For example, we can use 5 zeros, 1, 2, 3, 4, 5. We don't care about the first 5 bits, but for the other 3 bits, if the user has a permission, we will use 1, otherwise we'll use 0. So if the user has only the read permission, we will use 1 for the read. And for write and execute, we'll use 0. Similarly, if the user has read and write permissions, we can represent this permission using this binary number. And finally, if the user has all these permissions, we can represent that like this. Now, this is where we use bitwise operators. So I'm going to delete these 2 lines as well as these few lines on the top. Let's see how we can implement this access control system using bitwise operators. So I'm going to define a constant called read permission. Now I need to set this to a decimal number that is equivalent to this binary number. That decimal number is 4. Again, you can use an online converter to get this. Similarly, I'm going to define another constant, write permission. Now, what I want now is the decimal representation of this binary number. So all these bits or flags are off, only the right flag is on, okay? So this binary number 10 is equivalent to 2 in the decimal system. And finally, execute permission. So what we want is the decimal representation of this binary number. All these flags are 0. Only the execute flag or the execute bit is 1. And that number is 1. Now, I can declare a variable like my permission, initially set that to 0. Now I can give myself extra permissions. So I can update my permission like this. My permission, here we applied the bitwise OR to add a permission, like read permission, as well as the write permission. Okay, now let's take a look at the value of my permission on the console. So we get 6. Now technically, we don't care about this decimal number. We can use the bitwise AND operator to see if I have a given permission. So here's an example. I'm going to declare a variable. Let's call that message. Now here I'm going to use the ternary operator, the conditional operator. Remember? So we start with a condition. We take my permission and use the bitwise AND operator along with the read permission. Now, if this evaluates to true, that means I have the read permission. So let's say we want to display a message like yes. Otherwise, we want to display no. Let me break this up into multiple lines so you can see clearly. So here's our ternary operator. We have a condition. If that evaluates to true, this value will be used. Otherwise, this other value will be used. Finally, let's log this message on the console. So I have the read permission. But if I remove this read permission here and save the changes, now you can see my read permission is gone. So here's what I want you to take away. With the bitwise OR operator, we can add permissions. And with the bitwise AND operator, we can check to see if we have a given permission. Of course, this is just one real-world use case for using the bitwise operators. There are other use cases, but as I told you before, they're really not that common. So if this lecture was confusing, don't worry about it.